I think one of the key things to understand in history of science classes is that history of science is about people. And on the next few slides, if you choose to look at them and listen to the little vignettes that come along with them, you'll get some sense of some of the key people who you would meet if you chose to take history of science and origin of knowledge during the second semester coming up. Thanks for taking the time to listen. Here we see a photo of Albert Einstein at the height of his powers here in the early 1900s. He had just done his work on relativity, on quantum theory, and also on atomic theory. A great scientist, but a questionable human being in many respects. To continue his work, he left his wife and young children and didn't really serve as their father. How's this for a superstar? Here's a picture of Einstein at 76, long after he did his important work. But we've got an 8-column banner headline. The only time you see these is when people walk on the moon or war is declared. And here we have this man still that much of a consciousness in the public mind that he deserves this response at his passing. There are many historical characters who kind of receive a lot of hype. The greatest this, the greatest that, and may not be deserving, really. Not so with Marie Curie, winner of 2 Nobel Prizes, first woman to win a Nobel Prize, the first person after whom an element was made. More importantly, in this picture we see a young widow with 2 children. Her husband has just been killed in a terrible traffic accident, and she has to both raise them and continue her work. You can see the seriousness in her eyes here. The older daughter, on the right, ends up winning a Nobel Prize of her own when she grows up. You can't hear the rumble of the cannons or the guns in the background in this picture, but they're there. This is Madame Curie again in a big, long gown or dress, driving a portable X-ray ambulance on the Western Front in France. She really understood X-rays at that point as well or better than anyone, and she set out to build a couple of these. The driver of the other one that we know about was the older daughter in the previous picture. I mean, this was a formidable woman. Ernest, Ernest, Rutherford's mother called to him as he sat out in the potato field, digging up some of the latest crop. She was waving something in her hands. It turns out it was a telegram. Telegrams are unusual here out in the literal and figurative ends of the earth in New Zealand, and she wanted him to see the telegram right away. She finally reached him, handed him the paper. He ripped it open, read it, and looked up at her and smiled and said, "Mother, I just dug my last potato," got up, wiped off his hands, and left the field. He went to Cambridge, where he worked for the rest of his life. We know him for that important experiment where he determined that the atom was made of a very dense nucleus and with mostly empty space surrounding it. Heisenberg, shown here as a young man, is already the head of Hitler's nuclear program in the 1930s. Brash, extremely bright, inventor of the uncertainty principle, for which he is known. He was also quite outspoken to the point where in Nazi Germany he came to the attention of authorities, and finally to Heinrich Himmler, who was second or third in command of the entire German Reich. He was given an order to appear at Himmler's office, and things did not look good, despite his position. He went home, told all this to his mother, who, it turns out, happened to know Himmler's mother. She wrote to her and said, "My son is a good boy." Uh, Basically, that was the gist of the letter. Mrs. Himmler spoke to her son, Heinrich, and when Heisenberg finally went to see Himmler, Himmler said that there wouldn't be any problem if Heisenberg kept his mouth shut in the future. All right, the Nazis are coming. War is in Denmark in 1940. The country is being overrun. And he knows he has to leave, and he's worried that one of his prized possessions, the real gold medal from the Nobel Committee, might be confiscated. So he goes into the lab, makes aqua regia, dissolves the gold, puts the solution with the gold in a big bottle with a nondescript label, and puts it up in the lab shelf. It's 1940. He comes back in 1945. The bottle's still there, hasn't moved. He isolates the gold, now a powder, sends it back to the Nobel Committee with a note asking them to make him a new medal, which they certainly do agree to do. Here we have an extremely improbable duo. The man on the left, Faraday, essentially completely uneducated. You know an awful lot more algebra than he did. However, he was a great experimentalist. He was a dyslexic who had a great visual sense, which is not unusual with dyslexic people, and he tended to see experimental problems and their solutions as wholes. He would actually see what it was that had to be done, and then later on he could break it down into elements to explain to other people and actually make his apparatus. Remarkable man. On the right, we have the great mathematician, James Clerk Maxwell, who is considered to be up there with Einstein and Newton in his abilities. And he set out to work out the mathematics for electricity and magnetism. And he said the way he had to begin his project was just to follow Faraday around, because he knew Faraday had these global pictures of everything. And gradually over time, he absorbed the Faraday-ishness of the whole thing, and went on to write a set of equations which are a monument to 19th century science. Just to try to give you a little sense of Faraday's picture of things, this is one of the concepts that he saw. You've actually probably in middle school taken a magnet and some iron filings and generated a pattern like this. Kind of simple, but it's a nice picture to see. Well, it turns out to have great significance in the operation of electric motors, electric power generators, and including, of course, today's new Tesla car. But this is the Faraday picture that you now carry in your brain. Things get a little more rough and tumble here when we take a peek back into the 18th century. Our first really important scientist, Lavoisier, the father of modern chemistry, who unfortunately happened to be a really good tax collector, was guillotined in the French Revolution. Rumford, sitting there in the middle, was a New Hampshire school teacher, fought in the American Revolution, and then became a spy for the British, then fought for the British, then headed over to Europe, and went to Germany and spied for the German against the British. A really kind of interesting life here. The stuff of movies, for sure. Finally, on the right, we have the one person we all know, superstar Benjamin Franklin. What made Franklin's experiment and his understanding of electricity very, very important was his invention of the lightning rod. This simple device represented the first time that theoretical science came up with a definitely basic, practical device which could save churches and buildings and gunpowder storage areas. And he did become, during his lifetime, a superstar. Well, we've all heard of cult leaders who get a bunch of people together, convince them to believe things and do things that the rest of us seem strange. Well, you're looking at a cult leader right here, and the member of his cult are the members of Western civilization, basically. He clearly developed the way that an approach, the way to look at nature, observe it, measure it. To understand nature, you have to study it. It seems a simple enough idea, and it's obvious to us now because he was such a good guru. But it wasn't so obvious at the time. When he approached the Pope and his entourage with the same idea that nature spoke for herself, and that's the way she should be studied, and not reading and interpreting scripture, as we all know, he ran into some terrible, terrible trouble. I wanted to include a comment on the second woman to win the Nobel Prize in Physics. It took about a half a century after Madame Curie for another woman to win. There were 2 points about this woman I want to make. One is that when I did my own graduate work, I had to make use of some of the excellent ideas that she developed. And secondly, that she did the work for which she received the Nobel Prize as a volunteer. It's hard to think of anything that characterizes the difficulties that women faced in science than this description of the volunteer Nobel Prize winner.